Welcome to this special episode of Frequency Matters, the RF and Microwave Update series. I'm Pat Hindle, and today I'm talking with Jeff Massman, Senior Manager of Phased Array Platforms at Analog Devices. Welcome, Jeff.
Thanks for having me.
Analog Devices is very active in the area of phased arrays and is kind of shaping the future of radar and connectivity. So, I thought it'd be great to discuss some of the key innovations and trends in phased arrays. What are the key benefits of active phased arrays in our world today?
Yeah, good question. So in today's world, active phase arrays or AESAs have become the backbone of our modern and connected society, and they are driving now all the advancements that we're seeing across 5G, weather radar, LEO satellite constellations. However, this really just scratches the surface. There are so many more applications spanning both commercial and defense sectors where AESAs are displacing their traditional antenna counterparts. And what really sets AESAs apart is their software reconfigurability. This allows them to adapt to changing needs in the market. And this is a fundamental and critical differentiator. As connectivity demands continue to grow, AESAs will become even more essential to allocate resources dynamically and just ensure reliable communications. And it's also worth noting that we live in a spectrum limited world, and it's becoming increasingly congested. And AESAs can provide the capacity and resilience that are needed to keep pace with the future.
And so, what are some of the key trends driving innovation in phased array ICs?
Yeah, so there's several trends. So first, power efficiency. Second, there's a push to moving to increasingly higher frequency bands. We're seeing a push to wideband operation as opposed to narrowband operation. And then finally, a miniaturization and integration trend. So basically, like our industry as a whole is pushing to put more and more capabilities into single chips or system and packages in order to boost performance and reduce cost, size, weight, and power, things like that. Now, as a backdrop to this, like the system architecture is also influencing these, say, IC trends. So we're seeing customers increasingly move towards hybrid and digital ASIC architectures that require a higher number of digitizers than they did in the past. And this comes back to trying to maximize again the flexibility of these ASICs, but also trade off between the cost of thermal management challenge as well as things like simultaneous multi-beam operations. So you have hybrid arrays on one side and digital arrays on the other, and those are some of the trends from an architectural standpoint that we're seeing. And from our standpoint at Analog Devices, we have to address both sides of the market. So you'll see products like the 8R 4000 and 4001 beamforming ICs that we're pushing out there to the community just for efficient ultra wideband operations for high speed hybrid beamforming systems.
And so, what challenges do manufacturers face in the phased array IC market, and how are these being addressed?
Yeah. It's an ongoing challenge for sure. But there's three, let's say, recurring themes that I'm seeing in the IC development market for phase arrays in particular: thermal management, wideband linearity, and big surprise, but cost reduction. So thermal management, one of the things we're seeing is power densities for these phase arrays continues to increase across the board, and to get there to address these market challenges, we have to invest in advanced like GaN technology and similar devices to get improved power added efficiency and address some of the heat dissipation challenges that these highly integrated phased arrays present. And then for wideband linearity, this is just a consistent recurring performance challenge that we face for let's just say demanding communication and radar applications in the field. field. So, and that comes back down to the power draw and thermal management of the first point. And then the third is cost reduction. So there's no one size fits all solution to this challenge. So one of the things that we're doing at ADI is in order to meet some of the different cost drivers and challenges in the phased array market, we're focusing on transceiver-based solutions as well as data converter-based solutions. So we have products like the 80RV 9010 transceiver that offers exceptional linearity and bandwidth. Um, but then we also, for let's say more high-speed digital processing applications, higher power draw opportunities in the market, we have the Apollo 80, 90, 88 digitizer as well. And beyond that, there are a few other factors to consider for phased arrays and phased array ICs. Scalability and integration are critically important. Everything needs to be in today's world a modular architecture. That seems to be a recurring request across the industry. So the idea is to have phased array building blocks that you can use to expand your capability, expand your communications network without significantly increasing the cost or complexity.
Yeah, there's a lot of trade-offs and challenges. But what role do digital antenna arrays play in the evolution of phased array technology?
Yeah, this is a transformative step in the history of phased arrays. Unlike traditional arrays or hybrid phased arrays, fully digital arrays handle the beamforming, the signal processing, everything in the digital domain. It's a beautiful cross section of the analog and digital in our world today, and what they ultimately allow is precise multi-beam operation and frequency agility for customers. Now, practically what this means for communications, you have digital arrays enabling, excuse me, dynamic bandwidth allocation and the ability to maximize channel capacity in any environment. For defense applications, they provide unmatched agility and adaptability for radar and electronic warfare systems. And I guess the other interesting thing to note is digital arrays were a concept initially propelled forward by through defense investments, but today digital arrays are now gaining traction in the commercial markets. So companies like ADI are now driving this transition with solutions for advanced commercial data converters that can actually deliver the scalability and efficiency needed for broad market adoption.
Yeah, analog devices in a unique position as they do the whole signal chain, so you can really bring a lot to the table. So, what are some of the potential breakthrough technologies that could further revolutionize the phased array industry?
Yeah, this is a little, let's say, speculative on my part, but there's a few, say, fundamental emerging technologies that I'm keeping my eye on. So the first, we're seeing a push for semiconductors to move towards advanced processing nodes. So whether 4 nanometer, 5 nanometer nodes, this will ultimately enable higher transistor density, reduce power consumption, better performance, et cetera, et cetera. And this has the chance to minimize IC design and just, again, pack more and more capabilities onto monolithic parts. The second, kind of going hand in hand with these 5 nanometer processes, is chiplet architectures and the chiplet ecosystem. And this will enable improved manufacturing yields, potentially cost reductions, and allow for incremental upgrades to these highly complex yet capable. And then again, building upon this trend, right? So you have the 5 nanometer, you have the chiplet architecture. Then really the next step in that ecosystem, if you will, of processes and technologies that could disrupt and really propel the industry forward further. You have 2.5D and 3D heterogeneous integration. So basically, we're looking to advance like work on advanced packaging techniques, whether it's glass interposers, stacked RF, anything that we can to reduce parasitics in our devices, improve thermal management, and just ultimately obtain higher density components. And then last, probably like most people in any industry in today's world, we are increasingly looking at AI. How can we work with, how can we exploit, how can we leverage AI? And so that we're seeing opportunities in the field to leverage AI for everything from design and optimization to accelerating, let's say, predictive maintenance, reducing development cycles, et cetera. So there's a lot of, say, uncertainty in how that's going to play out, but at the same time, a lot of opportunity. And, I guess some of my final thoughts are by investing at the very least in these types of technologies and more, commercial companies like ADI are in a unique position to help shape the future of our connected world and innovation across all sectors. So
Great. Well, thanks, Jeff, for talking with me today about phased array innovations and trends. It's been very enlightening, and I like your comments. To our audience, you can find more videos at videos.microwavejournal.com. Thanks for watching.